All right, welcome to section 9.7, linear and other relationships. This is a big section, and before you even come to this point, I'm going to ask you to make sure you've watched the other videos listed, all of these, before you join me in this video here. Pause the video often, complete the problems with me and on your own, and take this as slow as you need to here. So here are our topics, our objectives, our standards, and our vocabulary and concepts. So a linear function is a function whose graph lies on a line in a coordinate plane, and we sometimes refer to these as linear relationships. So we've got y equals mx plus b and f of x equals mx plus b, and you saw these in those other videos. So a key characteristic of a linear function is that a change in inputs and the corresponding change in outputs is always the same ratio. So the rate of change is constant. So the slope, the rate of change is always happening at a constant rate here. And again, you saw this in the video on slope. So just briefly, you can kind of see how we can look at these with similar triangles. And again, in your previous videos, you saw how the y-intercept works. The y-intercept is our b value, and that is the point at which our graph intersects the y-axis. So modeling real-world linear relationships, we can tell if we see a couple key characteristics. If there are two quantities that vary together, we want to check if the changes in one quantity and corresponding changes in the other quantity are always in the same ratio. If so, it's linear. If not, it's not linear. So when we talk about real-world problems, there's some kind of slope words and y-intercept words. So when we think about slope, we're talking about rate or per or each, like for each, per. These are the things that are changing at a constant rate. And for our y-intercept, we're talking about, the flat fee, the initial amount, the initial height. We're talking about what's happening at the beginning. All right, let's look at example 1. So the tropical orchid company sells orchids by mail order and charges $25 for each orchid plus $9 for shipping no matter how many orchids are ordered. Is this function linear? If so, define the independent, dependent variables, determine the slope, y-intercept, and write an equation. All right, so is this linear? What is changing here? Well, what is changing is the $9 is not changing. That's a flat fee. But every time you order an orchid, it's the same price. It's not different if it's small or large or anything. This is the same rate, the same charge for each orchid. So this is linear. Because for each additional orchid, there is a constant additional cost, right? The constant rate of 25. So our x, our independent variable, so our x is going to be the number of orchids, because what are we talking about? We're talking about the number of orchids and the cost. Your cost depends on how many orchids you buy. And cost is usually your dependent variable. So what's our slope here? Our slope is what changes each time. Our slope is the cost for each orchid. And our y-intercept, our b, is our flat fee, is our $9 shipping fee. So we could write an equation that relates these: y equals mx plus b, 25x plus 9. If you wanted to write it as a function, you certainly could, because this is a linear function. Let's do one more together. So a dance academy charges $20 to use the facility and $50 per hour of individual instruction. Is this function linear? So is this linear? Are we dealing with a steady rate? And the answer is yes. It is $50 per hour, so it is linear, because this rate doesn't change depending on if you have a less experienced teacher, a more experienced teacher. We're not talking about different rates here. We're talking about a steady, constant rate. So our independent variable, our x, well, we have time here, and we know that time is our independent variable. And so the other thing will be cost. All right, and so time, we could also say here like the number of hours. We could be even more specific. And so our m, what's changing? It's $50 per, there's a slopewood, hour. And our b, our flat rate $20 fee. And so an equation would be y equals 50x plus 20. Y equals mx plus b. Determine the cost for 15 hours of dance instruction. Well, 15 hours, hours is our x. So what is the cost? Determine the cost. So y equals 50 times 15 plus 20. So it would be $770. Go ahead and give these problems a try. Press play when you're ready to see the solution. And there we go. B was a little bit tricky, making sure you're paying attention to what your variables mean. Let's do another example. A small order coffee company charges $12 for each bag of coffee plus $3 in shipping no matter how many bags are ordered. Describe a function that this situation gives rise to. Then make a table, sketch a graph, and find an equation. Is it linear? How can you tell? All right, so let's first see what we've got here. Charging $12 for each bag no matter what, right? And then a $3 shipping fee. So this does seem linear to me because we're charging the same amount each time. But we can make a table here. So we've got cost. We know that cost is always going to be our Y. And we've got the number of bags of coffee. Well, let's say you buy 1 bag of coffee. See how that's independent? I just picked that number. Well, that would cost you $12 plus $3 in shipping, so $15. What if I bought 2 bags of coffee? Well, that would be 2 $12 bags plus $3 in shipping, so that would be $27. What about 3? Well, that'd be 3 times 12 plus 39. Oh, excuse me, plus 3 would give me 39. What about 4 bags? 4 times 12. And you can see that we're multiplying by the same number each time. And so I do think that this is going to be linear, but we can keep going. Let's sketch the graph. So these correspond to, this would be 115, this would be 227, this would be 339, this would be 451. Well, we're talking about money and bags of coffee, so we don't need any negative values here. And we did 1, 2, 3, 4. These are our number of bags of coffee. And over here we have our cost. Now our cost ranges from 15 to 51, so I'm definitely not going to go by ones here, but maybe I'll go, let's see, 1, 10, 20, 30, 40, 50, 60, 70, 80, 90. I might be able to do, yeah, I think I should just do that. 10, 20, 30, 40, 50. And the reason why is it would go off the graph there. Otherwise I would go by 5s. All right, so 115 is going to be about there. 227. 339 and 451, and what do you know? That looks pretty linear to me. And so and I would say yes, that this is linear. There's a steady rate of change, constant rate of change. And so our last question here is to write an equation. So this is going to be y equals mx plus b. And remember, we've got to fill in our m. So what are we multiplying it by each time? 12. And what's our flat fee? 3. And so there we go. And maybe even f of x equals is more appropriate because they're calling it a function already. And there it is if you want to see it written out a little bit differently. Let's do another example before you do a U-try. So to cook rice, you need to use 1.5 times as much water as uncooked rice, no matter how much rice you make. Write an equation that describes this relationship and explain why your equation is correct, and be sure to define your variables with care. All right, so let's just first start by making sense of this with a table. Water and rice. Okay, so to cook rice, you need 1.5 times as much water as uncooked rice. So if I have 1.5 times water, that would be 1 cup of rice, right? 1.5 times as much. And then if I had 2 cups of rice, I would do 1.5 times the 2 cups, right? And then if I had 3 cups of rice, it would be 1.5 times the 3 cups. I'm just trying to make sense of what we've got here. So if I had R cups of rice, it would be 1.5 times R. So I can see that pattern there. So the water is equal to 1.5 times R, where W is the cups of water and R is the cups of rice. And again, making sense using a table to kind of see how that would go helped me build this equation. And here it is written out if you'd like to see that. And then you go ahead and give these 2 problems a try. Press play when you're ready to see the solution. Here's our first one, and here's our second one, and we'll continue in the next video.